On December 2019, a new virus that caused a worldwide pandemic started in Wuhan, China. This virus is called as a severe acute respiratory syndrome coronavirus 2, which causes COVID-19. Since then, we often hear the term flatten the curve. But what does that really mean? First, we ought to know what compartmental modeling is. Compartmental modeling is used to model epidemic spread. This classifies a population into groups or compartments. On the onset of COVID-19, the World Health Organization used an SEIR compartmental modeling to forecast the outbreak. SEIR stands for the compartment that this modeling uses. Susceptible, those who are able to become infected. Exposed, those who are infected by the virus but are asymptomatic. Infectious, those who can spread the virus, and removed, those who either have survived or died because of COVID-19. To make sense of all of this, I'll simulate. Imagine that we have a set of marbles and we'll let them perpetually roll in a closed region. This represents our population's interactions. But what happens when the population is introduced with a COVID-19 positive marble? When this happens, the susceptible compartment will decrease as the infectious compartment spreads the virus. Initially, asymptomatic COVID-19 positive individuals are categorized to the exposed compartment. Knowing that they have low chances of spreading the virus, it is assumed that the exposed compartment has no infectious tendencies. After the incubation period of the virus, they will then move to the infectious compartment as they start to show symptoms. All of the infectious individuals will then either survive or die. They will then be a part of the removed compartment. You will observe that the number of individuals per category through time is graphed by a curve. This is the curve that we are trying to flatten. Flattening the curve is crucial for if the spike of COVID-19's positive individuals exceed the capacity of our health facilities, more people will die. To fully understand what these mean, we must know that these curves are governed with corresponding ordinary differential equations. Simply put, these tells us the rate of the change of the number of individuals per category through time. Whose factors are the population's effective contact rate beta, the incubation rate sigma, and the recovery rate gamma. For us individuals, what we can do is follow certain measures mandated by the World Health Organization, such as social distancing and mandatory travel ban. These measures primarily lessen the effective contact rate beta of the population, which in turn would lessen the rate of the change of the number of individuals per compartment through time, resulting to flattening the curve. If you would compare a population following these measures to that with an open economy, you would be surprised in how much this would flatten the curve. With the tens of thousands of people dying worldwide because of COVID-19 and a vaccine that is still yet to be available, flattening the curve is perhaps one of the most imperative things we should focus on. But will you take your part on flattening the curve?